So now we're going to see step number 5. So here is a circuit given. So in this circuit, these two are in parallel connection and this is a series connection. So they are asking us to find out the equivalent resistance of the circuit. In the second question, we have that we need to explain with mathematical logic whether the electric through all the resistances in the circuit are equal or not. Okay. So first of all, let's do the first one. So it's a very simple circuit. In this circuit, this and this are in parallel connection. So you can say that. So let's find the equivalent for these two at first. For these two resistance at first. One by 20. So 1 by Rp is equal to 20. 1 plus 1 P is equal to 2 by 20. So Rp is equal to 20 divided by 2. Rp is equal to 10 ohm. So the value of Rp, that means the equivalent resistance for these two for these two resistances are 10 ohm, and this Rp, this is Rp. So this Rp and this 20, which 20 resistance, 20 ohm of resistance, they are in series. So we can write now that equivalent resistance is equal to 10 plus 20 ohm, which is 30 ohm. So this is the equivalent resistance of the circuit. Simple circuit itself. But the trick part is the second question. So let's do the second question. So here it says that we need to explain mathematically that the electric through all resistance in the circuit are equal or not. Or not saying electric, or we can say that current. But current, so wrong one. Current through all the resistances in the circuit are equal or not. So in order to find out this, what we have to do is we need to find out the potential difference which is acting in between this entire circuit. So what is the amount of current which is exerted within this circuit? What is the amount of current? We know that equivalent resistance is equal to, from the previous question we got, this is equal to 30 ohm. V is equal to 3 volt, and I, let's find out what is I. So we know that V is equal to IR. So I is equal to V by R. So value is very, very less. So I is equal to 0.1 ampere. So this is the amount of current, this is the equivalent amount of current in total, that is the current is working within this circuit. But in this question they are asking that what is the current through all the resistances. There are three resistances. Remember, this is the current which is going, and this is the equivalent current of this entire series, okay, entire circuit. But in this, for this specific resistance, there is a certain current. For this, there is a certain current, and the same current is going in this resistance and in this resistance because they are parallel to each other. So same current are going in these two resistances, but in these resistances are different current is coming because this is in series. When it is coming from here, the current is changing because we know due to resistance the value of current changes. So the value of currents are different in these resistances. So we have to find the value of current. So I is equal to 0.1. This is for the entire circuit. Now let's find out what is the potential difference. Now within these two are parallel circuits. Right, so what is the potential difference acting in between these two circuits? So let's find that out. IRP. So RP means the resistances which are parallel to each other. So V is equal to 0.1 into RP, which is 20. So V is equal to 0.1 into 20 is equal to 2 volt. So by using this V, we can find out what is the amount of current is passing through these two resistances. Okay, so R1 and R2 is the same current is passing. So we can say that current through R1 and R2. Let's call this R1. Let's call this R2, let's call this R3. So I is equal to V by R. So I is equal to 2 divided by RP. Now what was the value of RP? RP was 20. Okay, this is for, let's find out for R1 at first, then R2. So V by R1, this is for R1, and then we'll find for R2 and R3. So 2 divided by R1, the value of R1 was 20. So I is equal to 2 divided by 20. 2 divided by 20, 0. There is a correction. V is equal to 1. Okay. See, this V, which is 2, and the initial V that we have is this RP, this must be 10. Okay, so RP was 10, so it was 1. So there is a correction. The value of RP was 10. So here the value of V will be 1. Here it will be 1. So 0.05, 0.05. So this is the amount of current passing through R1. Now for R2, what is the amount of current passing through it? Same formula, V divided by R2 now. Now R1 value was 1 and R2 value is 20. So same 0.05 ampere. Now for R3, V divided by, sorry, not R3, I3 is equal to R3. V divided by R3. So V was 1 and R3 is 20. So this is also 0.05 ampere. So for R1, the current passing through R1 is 0.05. The current passing through R2 is 0.05, and also from R3 is 0.05. So we can say the current which is passing through all the resistances are equal. So this is the solution of this problem.